Once I have the setup defined, I can begin adding my toolpaths. In general, 2D toolpaths are used to machine models with vertical and horizontal surfaces. In 2D milling, the tool moves in the Z-axis, and cutting is done parallel to the XY plane. And with that, it's all feature-based. 3D milling allows for machining models with more curvature, contoured surfaces, more of those free-form type models, and therefore the references are more surface, faces, and edges on the model. In milling these contoured surfaces, specific roughing and finishing toolpaths exist as compared to in the 2D milling where there are fewer toolpaths and the same type of toolpath can be used both for roughing and finishing based on how you kind of customize the options inside of it. As you can see in my images, there are a few more 3D toolpaths that can be used for the refined finishing. In the limited time that we have here today, I can't explain all of the toolpaths and their options. I do aim to explain the overall workflow to create a toolpath so that you're super familiar with the interface and really can begin generating your own toolpaths when you get back to the office. Whether you're creating 2D or 3D milling or even drilling toolpaths, the toolpath palette is always used. The options and parameters that will be presented on this toolpath are all based on the type of operation and toolpath that you're actually selecting. The key thing here to keep in mind is the interface. So what you really want to focus on is that. In general, the first toolpath that you would be looking to create in most of your models will be a facing sequence. So I simply chose this as my example to show you kind of the overall palette, how the tabs look, that type of thing. To begin, when you're looking at this toolpath palette, you always define your tool first, the first tab that's available, and this is simply done by selecting the tool from a library. I don't have time to get into all of the tool library specifics. There's definitely more explanation in my handout. At a high level, what you basically do is you select a tool from the standard inventor library or custom library that you might have set up for your company, and you want to select the tool that would be best matched for your operation. Once you've selected the tool, it's assigned and it gets listed at the top of the palette, and then all of the data for that specific tool also update in the feeds and speeds section. The next step is to define the geometry that you're going to be cutting. So conveniently, this is all done on the geometry tab, which is the second tab. Inventor CAM does a great job at pre-selecting the geometry and making assumptions on what is going to be cut, but you also have the flexibility and the option to refine this at any time. In this case, it's the first operation, it's a facing operation, so the entire top of the stock contour was selected, so I'm not going to need any further changes here. The heights tab is the next in the sequence, and assumptions on the height are also made very well here. You may need to make some considerable changes, or you might not need to make any, but it's always good practice to review the heights. Each height is color-coded to match up with the setting. I also find that it's really good to review these in a 2D view, so I would reorient my model to 2D so that I can actually see the heights above the stock to make sure that I'm making the right changes. The passes and the linking tabs are the final two tabs that are required to define your toolpath. They define how the tool makes the passing cuts and how the passes are all linked together. The default settings on these tabs, among others, are very generic settings that would commonly be used. I tend to focus on my tool, my geometry, verifying my heights, and then I go with the default settings on these tabs initially as a great starting point. And then from here, I can then review the resulting toolpath and then go back in and make edits to any of these parameters as needed. As you gain more experience with the options and how they'll affect the actual outcome of the toolpath, you'll be able to start setting these in your initial definition. But this is really a great way to get started. As I get into my demonstration, we will create additional toolpaths and the list of options will get larger. This can be a little overwhelming and the option name's a little confusing. So I just wanted to show you a quick screen grab here. The Autodesk Help tool is actually very well done here, and you can hover your mouse over any of the options and a tooltip appears. And generally they all have really great imagery as well to help describe the actual option and value that you're going to be defining. So I use this a lot as I got used to this tool. And finally, once you click OK and you complete the toolpath is added into your CAM browser, as you can see in this image. And as well, once you select that, the actual toolpath is displayed on your model. Blue represents the cutting path. Green is the lead in and lead out movements. Yellow are the tool rapid movements. The green and red arrows obviously show the start and the end point of the toolpath.